In this introductory chapter, we have seen the concept of the physical state, which is just a collection of variables that specify the conditions under which a sample is. Now, we have to specify the state of matter as part of the physical state, and then we have to specify also the amount, volume, pressure, and temperature. Okay, so let me write that those last four variables in turn, right? So the amount can either be the number of moles, which is N, or the mass M, and then you have volume, pressure, and temperature. Now, we have talked about each one of these in turn, and the last variable that we have to talk about is temperature, which is fairly straightforward. Now, everybody has a really good intuition about what temperature is. We say that bodies that are hot have a higher temperature than bodies that are cold. And that is fine. That is actually a fair way to understand what temperature is. But from a thermodynamic perspective, temperature plays a really important role, and that is it tells you the direction of energy transfer between a hot object and a cold object. Okay, so let's try to draw here a small diagram to further clarify what this is. Right, so suppose that you have two bodies in contact with each other, and one of them is hot and the other one is cold. Right, so this may be maybe an ice cube in a bath of liquid water. Okay, so obviously those two bodies have a different temperature. Okay, so it actually tells you the gradient of temperature tells you the direction in which energy will flow, thermal energy will flow. Okay, so in this case, what we actually have is that energy will flow from the hot object to the cold object as heat. Okay, so as a matter of fact, we can actually write here already what this letter for that energy transfer will be. This will be heat, and we're going to be using the letter lowercase q to signify heat. Okay, so that is going to be the operational definition of temperature in thermodynamics. It's simply a signpost that tells you the direction of energy transfer as heat when you put into contact two objects that are a different temperature. Okay, so now if you actually let this system reach equilibrium, there's going to be a point in which, well, the temperature of the two objects will equilibrate, right? So when you reach that point, we say that that system is under thermal equilibrium. Okay, so what that means is that the amount of energy transfer has ceased, or that the energy transfer from this object to that object is exactly the same as the amount of energy transfer from that object to that object. And again, that happens when you actually reach something that is called thermal equilibrium. Now, let's talk about units then. The SI unit for temperature is the Kelvin. And again, I don't think that I can remember a single problem in which you do not have to use Kelvin as the unit of temperature. Again, I don't think that you can get the right answer for any problem in thermodynamics using Celsius as the temperature choice. Okay, so every time that you see a temperature that is not Kelvin, the first thing that you have to do is transform it into Kelvin. Okay, so to do that, remember that if you have Celsius, right, so the temperature in Kelvin and Celsius can be transformed directly as this. The temperature in Kelvin is equal to the temperature in Celsius plus 273.15. Okay, this is the 5 significant figures, even though for some problems we may be using only 4 or maybe just 3. Okay? All right, now notice that the temperature scales, Kelvin and Celsius, those temperatures are not directly proportional to each other. Instead, they're simply just offset, and that offset happens to be this 273.15 value that you have right there. Okay, so this is it really about the physical state. Okay, we have spent the last few videos talking about what the physical state is and defining the various components of the physical state: amount, volume, pressure, and temperature. And now we're going to be moving forward and try to define what an equation of state is. Okay, so from the physical state, you get to something that is called an equation of state. And that equation of state, the only thing that really tells you is that these four variables are actually connected, right? That means that if you actually know three of them, then the fourth is automatically specified. Okay, so you cannot have an independent value for these four variables ever. And that happens for any substance that you want. It can be pure, it can be a mixture, it can be a solid, it doesn't matter, right? If three of them are specified, then the fourth is known. Okay, so again, the next video we're going to be talking more about those equations of state, and we're going to concentrate on the simplest equation of state that it is, and that it will be the ideal gas equation of state, which is a concept that we have studied in earlier